Yes, good afternoon everyone. Here today I would like to start my presentation on electric vehicle thermal management. So here we are having different components: radiator, condenser, chiller, evaporator, cabin, heaters, right? And powertrain blocks here: powertrain, charger, motor, and inverter. You can clearly observe here. This is the powertrain components: DC to DC, charger, motor, and inverter, and the battery. And these are related with the thermal components, right? Radiator, condenser, chiller, evaporator. So here this system is having the two coolant loops. One is a refrigeration loop and another one is a cabin HVAC system. So this is the cabin HVAC system, this port, and a refrigeration loop also it is having. So here it is indicated in orange and blue color lines. So altogether we are calling it as a refrigeration loop. And some other loops like thermal, batteries, and the powertrain, and the cabin, this cabin, battery. So these are called the thermal loads. So where the heat will be produced here. And the two coolant loops can be joined together in the serial mode. Two coolant loops we are having. Two coolant loops. They can be joined in a serial mode or in parallel mode using a four-way valve switch. So this is a four-way valve switch. So we are having two coolant loops and we are having three different temperature scenarios. One is cold weather condition, another one is warm, means with less, it is completely cold conditions. Warm weather means lightly heated conditions, and hot weather, highly heated conditions. So with the in the cold weather, these coolant loops are in serial mode, so that the heat from the motor warms the batteries. So this is one coolant loop. You can see radiator is forming one coolant loop, and another one is, see, pump, condenser, chiller, evaporator. So this is the second coolant loop. So these coolant loops are in serial mode. In the cold weather condition, these two are in serial mode. Radiator, you can see here, this AB will come here, and it will go in this way, and it will close us here. So all are in serial mode, so that the heat from the motor warms the batteries. So the heat from this motor will heat the battery now under cold weather conditions. So motor itself is producing a heat for the battery. And if this heat is not sufficient, which is produced by the motor, then the heater will be enabled. Then heater will produce the enough heat for the battery. Okay. No. So this is under cold weather conditions. How we are getting the heat? Either from the motor or from the heater. Either from the motor or from the heater we are getting. And in warm weather conditions, means lightly heated conditions, right? So the coolant loops remain in the serial mode, in the same serial mode they are operating, and both the batteries and the powertrain are cooled by the radiator now. So now it is lightly heated now. So we have to cool the components now. We have to cool the battery and this DC to DC converter, charger, and the motor and the inverter. So these will be cooled with the help of a radiator now. So this radiator is producing the enough cooling for the batteries and the powertrain. This is the powertrain. So this radiator is producing now. Now under hot weather conditions, means where we will get a more heat. So the coolant loop switches to the parallel mode now. The coolant switches to the parallel mode. So one is operated by the radiator. This is another switch. First one, this is the second one. So one loop cools the powertrain by using the radiator. With the help of this radiator, with the pump. So this powertrain is being cooled now, right? And the other the other loop, this is the other loop, it cools the batteries using the chiller in the refrigeration loop. So it takes the help of chiller and condenser and the evaporator, and it is cooling the batteries now. Okay. So these two are operating in parallel modes now. So these three are the different temperature conditions. These all are operated using the four-way valve switch here. So this is the refrigeration loop. It consists of a compressor. One is refrigeration loop, and another one is the HVAC loop. This is the HVAC loop. So in the refrigeration loop, it is having compressor. This is the compressor, condenser, chiller, and a liquid receiver. Expansion valves. These are the expansion valves. This is one more expansion. Two expansion valves we are having, and an evaporator. So this chiller here is used to cool the coolant in hot weather when the radiator is not sufficient. Radiator is providing the cooling actually. Okay, if that cooling is not sufficient to cool the coolant, then we will take help of chiller now. Then chiller will cool the coolant. Chiller is used to cool the coolant in the hot weather conditions. And evaporator is there. It is used to cool the vehicle cabin. So whatever the heat produced here, that will be evaporated now with the help of an evaporator. So the evaporator is used to cool the vehicle cabin when air conditioning is turned on. So whenever heat is there, we will take the help of the air conditioner. When the air conditioner is switched on, whatever the heat is there, that is evaporated now, and it's producing the cool weather conditions. The compressor is controlled. This is a compressor. It is controlled such that the condenser can dissipate the heat absorbed with either chiller or evaporator. So it will create some different pressures for the coolant now, such that the condenser can dissipate the heat. By either chiller or evaporator. So it will increases the pressure so that the condenser will evaporates and it produces a cooling condition. Now HVAC and chiller and evaporator are also involved in producing the cooling now. The second one is the HVAC loop, this part. It consists of one blower, it's nothing but a fan, and an evaporator and a heater, PTC heater, and the cabin. So the PTC heater provides the heating in cold weather. It produces heating in cold weather condition. The evaporator provides air condition in hot weather. It will produce air conditioning in hot weather condition. And the blower here is controlled to maintain the specific cabin temperature here. So next, the parallel or series mode valve subsystem. This is the parallel or series mode valve subsystem. So a four-way valve in the subsystem controls whether the coolant loop operates in parallel or series mode. So two coolant loops we are having, whether they are operated in series or parallel will be decided with the four-way valve system here. So when the ports A and D are connected, A and B are connected, and port C and B are connected. Port C and B are connected. It is in parallel mode, so it is operating separately and it is operating independently. So here one pump is there, the radiator, coolant is coming from the radiator and the pump is pumping the coolant to here. So it will cool down the power train here. And one more cooling circuit, we are taking help of this pump and chiller and the evaporation circuit. Then we are cooling the battery here, right? So this is the parallel mode. Two coolant loops are separated with their own coolant tanks and pumps. This is pump 1 and pump 2. Now when ports A and B are connected, now when A and B, just I will take some other color here. Now when ports A and B are connected now, A and B are connected here, C and D are connected. C and D are connected. It is in serial mode. Means you can see here radiator. This is the direction, pump, and it is subdividing chiller, and it is coming back in this fashion now. And again it is going to D. So it's going in this fashion. So all are connected in series mode or serial mode, right? So the two coolant loops are merged and the two pumps are synchronized to provide the same flow rate. So these two pumps and all the components are in serial mode. So they should produce the same flow rate now. So parallel mode flow path is AD, A, D, B, C. Parallel mode path is AD and CB, right? And in the series mode, AB and CD. So this is the series mode here. Now just I will explain each and every individual components. What is a motor pump? So this is the pump you can see here. Pump. So the pump drives the coolant loop that cools the charger, motor and the inverter. So it is only pumping the coolant. It is only pumping the coolant into the cooling components, right? So that it is cooling charger, motor and the inverter. The radiator. So the radiator is a rectangular tube and fin type heat exchanger that displays the coolant's heat to the air. So one fan will be there, the airflow is driven by the vehicle speed and the fan located behind the condenser. So radiator, what it is doing, it dissipates the coolant heat to the air. Coolant is used to cool the environment there, but if it is having some heat, that will be dissipated with the help of a radiator. And the radiator bypass valve subsystem. Radiator bypass valve subsystem. In cold weather, what is the functioning of radiator? In cold weather, radiator will not be function, so it is bypassed so that the heat from the power train can be used to warm up the batteries. So in the cold weather, we have to warm up the batteries. So the power train is producing the enough heat for the battery, and under hot weather conditions, it has to be enabled radiator. So this is controlled by a three-way valve. It sends either coolant to the radiator or bypasses the radiator. I will show you. So this is a three-way valve. It sends either coolant to the radiator, it pumps the coolant to the radiator, or else it bypasses, this is the circuit for bypassing. So it's keeping radiator in idle position now. It will not enact under warm weather conditions, right? Now battery pump subsystem. So this pump drives the coolant loop that cools the batteries and the DC to DC converter. So this is the battery pump subsystem. It is cooling down the DC to DC converter and the battery also. This is pump 2. This is pump 1. Next, chiller subsystem. So chiller is assumed to be a shell type and a tube type heat exchanger that lets the refrigerant absorb the heat from the coolant. So the chiller, if some heat is absorbed by the coolant, means coolant is got of heated, so that heat will be reduced with the help of a chiller subsystem. So it lets the refrigerant absorb the heat from the coolant. Okay. And the chiller bypass valve subsystem. So the chiller operates in an on-off manner depending on the battery temperature, and it is also controlled by a three-way valve. Either sends the coolant to the chiller or bypasses the chiller. Here also same conditions. Under cool conditions there is no involvement of the chiller, but under hot conditions the chiller will be involved. So this is the circuit chiller. Okay. Again with the help of a three-way valve, chiller circuit can be enabled or disabled here. This is a three-way valve. Either you can send the coolant to the chiller, or else you can bypass here, Now heater subsystem. This is the heater, right? Heater subsystem. So heater, it will produce the enough heating when the battery heater is modeled as a heat flow rate source and a thermal mass. It is run in cold weather conditions. Under cold weather conditions, heater will produce the enough heat to bring the battery temperature above 5 degrees centigrade. Okay. Next, DC to DC subsystem. This subsystem models a coolant circuit around the DC to DC converter, which is represented as a heat flow rate source and a thermal mass. It's a battery subsystem. So this is a battery subsystem. So already we have discussed how to construct a battery. Here we are having a battery of 4 series connected battery modules. All modules are of the same size and type. Each module consisting of 2 parallel pouch type cells, a series of 20 such rings. So overall 160 cells will be there. The battery being equal to 160 cells, total number of cells, 160 cells. And compressor subsystem, compressor. So this is a compressor, right? This is compressor. It will produce some pressure here. The compressor drives the flow in the refrigerator loop. It is controlled to maintain a pressure of 0.3 pascals, megapascals in the chiller and the evaporator. To maintain the pressure, compressor is used to maintain the pressure of 0.3 megapascal in the chiller and the evaporator circuit. Next, condenser. Condenser is also used to cool down the coolant temperature. The condenser is a rectangular tube and pin type heat exchanger that dissipates the refrigerant heat to the air. So chiller and the condenser functions in the same way. Here also the airflow is driven by the vehicle speed and the fan. The liquid receiver processes the storage for the refrigerant and permits subcooled liquid to flow into the expansion. And chiller expansion valve subsystem. Expansion valve. So this will meter the refrigerant flow to the chiller to maintain the superheat. And evaporator expansion valve subsystem. So it will provide some cool to expand the coolant, right? Chiller expansion valve and the evaporator expansion valve. So this provides a cool for expanding the coolant now. Evaporator subsystem. It is a rectangular tube heat exchanger that lets the refrigerant absorb the heat from the air. So evaporator is used in the HVAC cabin. So it will absorb the heat from the air here and it will sense out with the help of a blower. Blower subsystem. The blower drives the airflow in the HVAC loop. Okay. It is controlled to maintain the cabin temperature set point. And PTC subsystem. It is a heater. It is turned on in the cold weather. It provides the heating to the whole vehicle cabin here. And the cabin subsystem. It is modeled as a large volume of moisture or air. So this is regarding the PV thermal management. And next, I will show you some terms which we will use in the coolant loops or heating loops, right? In the HVAC systems. First, what is chiller? We will check. I will start from here. Wait for a minute. First one is compressor. So it is a compressor. It is providing the enough pressure for the system, right? It is a device, mechanical device that increases the pressure of the gas by reducing its volume. So it will compresses the volume and it creates the pressure. So these are the compressors. It is creating the pressure with the gas. And next, a condenser. So some liquid will be flown with these tubes. The liquid will be getting cool now. Getting cool now. Some water will be thrown onto the tubes so that the liquid will be cooled down now. So we will made it to pass through this all. So here refrigerant is there, refrigerant. So some water will be poured on to these tubes so that it will be cooled down. Refrigerant will be cooled down. You can see here. So gas will be there here inside. And another one, liquid receiver. So you can see here water cooled condensers. So these tubes will be passed on with the water so that it will be getting cooling. Condenser and a liquid expansion valves. One more component is expansion valves. The valve will be very smaller in diameter, it is larger in diameter. So it will provide a room, right, for expanding. The same gas, if you are making it to pass through this valve now, so the pressure will be more, and the same will be if we make it to pass with this valve now, so the pressure will be less now, it will be expanded. So expansion valves are used, and a chiller. So this is the cooling tower or chiller unit. It's nothing but a cooling tower. And an evaporator. So if you take a HVAC cabin, whatever the humidity is there, it will try to evaporate the humidity now. So this evaporator is trying to evaporate the coolant here. Blower is nothing but a fan. So these are the components that are used in the thermal management systems, right? Thank you. I am stopping my lecture.